So in this discussion we will discuss this indefinite sum and closed form. Okay, so what is actually closed form of a sequence? Okay, so a sequence an is said to be hypergeometric or a closed form if an divided by an minus 1, that is nth term, n divided by n minus 1th term, ratio of these two terms, this is equal to pn divided by qn is a rational function in n. Okay, rational function in n. So therefore, hence we can say that this is in closed form. If I cross multiply it, this must be equal to 0. Or from the previous section, you can see this is actually our given sequence, so an minus 1, so you can use the shift operator n. Okay, n, because if I consider original sequence a n minus 1, then shift operator will give this is an n, so qn n minus pn is a recurrence operator of first order. Okay, this is a recurrence operator of first order. So this is the definition of closed form. Okay, so now you see, to every sequence we can have the corresponding indefinite sum. Just you remember, you can construct sum of a sequence. So how do you construct the sum of a sequence? Say S1, first term will be S1 will be A1, S2 is nothing but A1 plus A2. So proceeding in this way, so you can write down, so an is nothing but Sn plus 1 minus Sn. Okay, because Sn plus 1 is nothing but S1 plus A1 plus A2 plus AT up to an plus 1 minus S1 A1 plus A2 up to an. So this will cancel out, this will give an. Okay, so an can be written in this way. So to every sequence an, there corresponds an indefinite sum. Indefinite sum means that is, this is not finite, where an can be written in this way. So there is a algorithm which is known as Grosspar algorithm. So Grosspar algorithm, given a closed form an, closed form, when is the independent sum sequence also closed form? A closed form is given and you can construct the corresponding indefinite sum. So whether this indefinite sum is closed form or not, that is the question. So according to this Grosspar algorithm, so you can have this answer. So the Grosspar algorithm is nothing but systematic steps. So the systematic steps are written in a very simple way. So what is the system? What are the systematic steps? So input is a closed form an. This is a closed form an. Closed form means this condition is satisfied. Okay, this is the closed form. The sequence is said to be closed form. You can write down this expression. Okay, so it is a closed form. Then set an divided by an minus 1 in this way, where pn is of maximal degree. Okay, objective is to pn is of maximal degree. First step. Second step, you have to consider fn is equal to I from 0 to L finite, that is fi n to the power I in indeterminate fi. Okay, that is we are going to find out this f1, f2, f0, f1 up to fl, and solve the equation. This equation we have to solve. Okay, so fn is written in this way, and we are going to find out this indeterminate fi. We will find out this and solve the equation this. If no solution exists, then Sn is not closed form. Okay, no solution exists. If solution exists, then you just write down Sn plus 1 is equal to this. This is Sn plus 1, an qn plus 1 divided by pn into fn. So this is the actually desired indefinite sum with an is equal to Sn plus 1 minus Sn. Okay, for definite sum, that is if we have the restriction for definite sum, we does obtain just I from 0 to n ai. Just you put the value of a0, a1, a2 up to an, then a0, a1, a2 up to an from here. Okay, just put the value, then you can have this result. Similarly, if I start from r to n, you just put the value accordingly. ar plus 1, ar plus 2. Okay, you just omit this term ar and put the value of ar plus 1, ar plus 2 up to an, then this will give this. For sum, starting index are. Okay, so take an example. This example, this is in the book, but I will have the solution in my copy. So this is the example. An is given in this way, where n is greater than equal to 1. Remember, here n is greater than equal to 1, not equal to 0. So step 1, an by an minus 1. This is our an by an minus 1. Okay, so after a little bit calculation, we can have this result. So therefore, this is in the form Pn divided by Pn plus 1. Okay, Pn divided by n minus 1. Sorry, not Pn plus 1. This is Pn minus 1. This should be Pn minus 1. Pn minus 1. This is Pn minus 1. Okay, this is in terms of Pn minus 1. So this is of maximal degree. Therefore, this will be Pn. So these two terms, the maximal degree, this is the maximal degree Pn. So Pn is this, Qn is this, this is our Rn. So we have to write down this Fn in this way, Fi Ni I from 0 to L indeterminate of Fi, and we solve the equation. This is the equation. So if I put the value Qn plus 1, what will be the Qn plus 1? This will be n. Fn, we are going to find out Fn actually. So Rn is 1, and Fn minus 1 equal to 1, Pn equal to this is our Pn. So this is this. So this equation, whether this equation has a solution, what is the condition or not. So left hand side, right hand side is a polynomial of degree 2. So here Fn is a polynomial in n. Okay, since these two polynomials are equal, means this is a polynomial of degree 2. So if this is a polynomial of degree 2, then n into Fn, that is Fn is a polynomial of degree 1. Okay, so therefore Fn must be a polynomial of degree 1. So therefore this is the standard form of a polynomial of degree 1. Okay, Fn is equal to f naught plus f1n. Okay, standard form. Okay, so Fn is nothing but, from here we can conclude that Fn is nothing but f naught plus f1 of n, because this is a polynomial of degree 1. Polynomial, this is the standard form of degree 1. So you just remember polynomial of degree 1, ax plus b, something like that. Okay, in terms of x. So just put the value Fn, put the value here Fn. Okay, and Fn minus 1, and corresponding the equation, equating the corresponding coefficient of n square n constant term, you can have f1 is equal to 1. This is simple observation. So f naught minus f1 is equal to 1. So therefore f1 naught is equal to this. Similarly Fn, Fn is equal to 2 plus n. Okay, so we have this Fn equal to 2 plus n. Just put the value of f naught and f1. So f naught and f1, 2 plus n. Okay, so since it has a solution, therefore this is our indefinite sum, Sn plus 1. So Sn plus 1 is this by the algorithm. So put the value. Okay, little bit calculation, you can see this is Sn plus 1 equal to this. Now if I find out the definite sum, here you observe that I starting from 1, not from 0. So 1 to n, this is ai, this will be Sn plus 1, and this is actually S2, in our previous case S1 plus A1. Okay, A1. So this is Sn plus 1 is this, S2 will be, S2 is equal to 3. Just put n is equal to 1, you can find out S2. Okay, S2 will be S2 will be 3, n is equal to 1, put this is 3 into 1, 3. And A1 is nothing but here from A1. So what is our A1? A1 is this is our A1, n is equal to 1, substitute n is equal to 1. So this is actually 1, n is equal to 1. Okay, so therefore we have this result. This is the definite sum. So this is the corresponding indefinite sum, and definite sum and indefinite sum. And next example, whether this is a closed form or not, we have to verify it. So that it is not actually closed form. In the indefinite, the definite sum is not in a closed form, because you can see, just you consider here an is equal to factorial n. So if I consider this one, an by an minus 1, so this is this n. Okay, so here you can see, though it is like n, the Pn should be maximum degree. Okay, so degree of Pn, from this observation, Pn should be 1, degree of Pn should be 1, but we have this standard form, an divided by an minus 1 should be in this form. Okay, so if I consider Pn is equal to n, then there is this should be n minus 1. There should be in term n minus 1, but this is not here. So you have only n. So therefore degree of Pn must be equal to 1, and Qn you have to consider this must be equal to n. Okay, so Rn equal to 1. So though degree is maximum, it is given that Pn is of maximum if an by an minus 1 is of the form. Okay, is of the form, then you just consider maximum degree of Pn. But here the maximum degree of Pn in this case, this must be equal to 1. So here R is equal to 1. So you just consider functional equation. Okay, just you consider a functional equation. So if it is a closed form, then here you can see. So in the right hand side, there is a polynomial of degree 0, but Fn, this Fn is a polynomial. Fn is a polynomial. So here n plus 1 into Fn. So degree of Fn cannot be equal to 1 because there is a term n plus 1. So therefore this clearly has no solution. Therefore this is not a closed form. Okay, so next video we will discuss the later part.